Now here is the contents that I have been, the mentioned. And as a consolidated statement in this particular talk, I would like to explain the, the different aspects of the energy management strategy of a fuel cell hybrid electric vehicle, and absolutely the performance optimization techniques employing these different AI approaches in this context. Now, at the very basic part, actually, the fuel cell hybrid electric vehicle is one of the uh, prominent invention in the electric mobility solution, and it is one of the tremendous technology that the Western countries are presently, the adopting as compared to the conventional, the battery electric vehicles, or the hybrid electric vehicles exactly. With the basic property of the fuel cell technology that we do have, that fuel cell is a kind of technology which produces normally zero tailpipe emissions. So means in the perspective of the environmental sustainability as compared to the conventional electric vehicles as well as the battery electric vehicles. Now, fuel cell electric vehicle technology, rather the fuel cell generation is basically converting the chemical energy of the fuel into electrical energy, as a very basic common phenomena that we do have. And fuel cell is essentially composed of the two plates separated or isolated by a membrane exactly. And while we do have the anode and cathode, the hydrogen is basically passed through the anode and oxygen is passed through the cathode. And at the anode, hydrogen molecules are basically splitted into electrons and the protons by the catalyst. So you could see the negative, the particles cannot pass through the membrane, and positive, the positive part of the particles can easily pass through the membrane exactly. So in this context, the electrons are forced through a circuit and generate the electricity and heat. So means the product of this reaction are basically the H2O, that is the water that we need to have, and H2O may be decomposed into H plus plus, H plus, and OH minus, actually hydroxyl ion and hydrogen plus ion exactly. So in this case, that we could conclude that a fuel cell is basically a combination of the fuel and oxidant, and that the reaction is so called the electrochemical, the reaction, and ultimate the outcome is that the electricity is getting generated. And we could see that as compared to these conventional battery electric vehicles exactly, rather IC engine vehicles, the fuel cell hybrid electric vehicles is 2 to 3 times more energy efficient as compared to the internal combustion engine that we do have exactly. And last but not the least, the fuel cell stack is very quiet in operation. No rotating parts is there. Hence, we could conclude that zero emissions, or the environmental pollution in terms of the greenhouse gases are significantly the reduced in case of the fuel cell technology as compared to the the battery or the plug-in hybrid electric vehicles that we need to have. So while talking about the pros and cons of the fuel cell technology, especially the pros that we need to have, the higher energy, the efficiency, and the zero emission is one of the very important point in this context. And the latter on, no moving parts in the stack, so we could conclude that the operation is quite silent and quieter exactly. But while compromising with this technology, we should definitely convey that the configurational cost or the installation cost of the fuel cell technology is definitely larger indeed as compared to the conventional, the battery electric vehicle, especially because the fuel cell stack is, the very costlier indeed, and definitely the hydrogen gas has to be filled over there, and you need to have a concrete tank, and at a transportation is one of the very important context that EV engineers are basically working on that to integrate this particular technology. But one thing that is durability is maybe one of the consideration, because the membrane and the catalyst that we need to have the lots of hazardous may be taking place, and later on I have already told you that is the hydrogen gas, the production, and definitely the transportation and the storage tank, that we need to have this particular storage tank and the refueling systems that we need to have, and injecting of the fuels and maintaining the particular consideration like the tank pressure, volume, etc. Is one of the important consideration to integrate the fuel cell technology. Here I would like to emphasize you that the one of the important context exactly that we need to have. Sorry for this delay. Yeah. So one of the important context that we could see that the one of the the energy storage. Yeah, I feel this screen is observable, na? Hello.
Yes, sir, we can see. Yes, sir, we can see your slide.
Yeah. Fine. Yeah. So while we are talking about the energy content and the power density, so means while we are looking forward, the concept of the storage technology in terms of the energy density and power density as compared to the battery technologies like the lead acid battery, the lithium ion battery, and the gasoline that we need to have. The energy density is one of the very important context while we are integrating the different sort of energy storage component, especially the power density and energy density, because it has a very stringent impact that while we are going to configure one particular energy storage component like a batteries that we do have, exactly because if we could see the energy density is solely associated with this that particular the continuous power supply, as well as the distance traveled by a particular electric vehicle. It is solely based on that condition, and definitely the particular weight and volume of the energy storage component is one of the very important context, that how much energy is basically stored for a particular weight of this the battery or energy storage component that we need to have. And as compared to the lead acid and lithium ion batteries, if we could take a consideration the hydrogen, which is one of the very important fuel inside a fuel cell technology. So energy density is very higher, that is 120 megajoule per kg weight of the particular volume, that which is could be summarized as 33 kilowatt hour per kg. That is the hydrogen is basically consisting of, as compared to the lead acid, the lithium ion, and the gasoline that we need to have. Here some of the examples of the fuel cell technology, and here I have been trying to embed you for the better understanding of this technology. So you could see the automotive fuel cell, the proton exchange membrane fuel cell, and Honda FCX Clarity is firstly discovered the fuel cell based hybrid electric vehicles technology, and the Nexo, the Hyundai Nexo. So here you could see the proton exchange membrane is one of the mostly widely used the fuel cell technology as because it has producing the zero emission, the quiet in operation, higher power density, and definitely the flexible operating characteristics. But in comparison with these, the drawbacks like the complex storage technology and the high end cost of the setup that we need to have. But here, what I would like to tell you that Honda FCX Clarity, that is the firstly invented fuel cell based hybrid electric vehicle technology. And if we could see the Honda FCX Clarity in the later on, if you could see the Mercedes, the Benz, and the lower one, that is the one of the important configuration, that is the fuel cell based the hybrid, the buses are basically the running in the different foreign countries. So here in the Mercedes Benz, the European, one of the important European project which is basically the running on the fuel cell technology. And you could see there are 30 fuel cell the buses can be operated on the roads of the Europe since the last few years. In the lower part, that is FCHEV bus 2, that you could see that the fuel cell stacks are basically embedded on the top floor of the buses, that is the rooftop exactly, and high pressure hydrogen tank has been incorporated over here to provide the adequate fuel for the propulsion power, that propulsion power that is the electromechanical energy conversion could be taking place in this context. And that you could see the Toyota is FCB bus 2 is a large low floor fuel cell hybrid bus technology, where the battery is there, the fuel cell stack is there, the power control unit is there, and definitely electric motor must be connected inside the powertrain, which is solely responsible for the conversion of electromechanical energy conversion process. But inside this technology, lots of power conversion could be taking place, and power conditioning is one of the very important, the requirement. And to meet this particular, the conversion of the DC to DC converters, and obviously the DC to AC converters is expected to be incorporated in the power configuration, and to feed the power to the modern context of the electrical, the motors, like it could be the EMSM, or whether it could be the brushless, the DC motors, and whether it could be the switched, the reluctance motor configuration that we need to have. Here in this particular technology, that how the fuel cell car is basically working on, that I have been trying to focus you to using one particular block diagram configurations. Here you could see the hydrogen tank is basically filled with the gas of hydrogen at a particular pressure and volume, and from the hydrogen tank, the hydrogen is basically provided to the the particular pressure regulator. So the regulating the pressure is one of the very important consideration inside the fuel tank, especially the hydrogen tank that we need to have. And air compressor and the coolant pump is definitely one of the viable configuration in this particular technology to mitigate the different sorts of thermal, the management that we need to have. And from this fuel cell that we could see at the output of the fuel cell, we may have one boost converter, that is one of the DC to DC converters, and depending on the duty cycle or duty ratio, you may have this configuration, that time ratio control or current limit control actually. And the particular boost converter can be designed depending on the load configuration or the output voltage configuration or the battery voltage that we need to meet over here exactly. So in between this boost converter and the battery, we need to have the power conditioning, and depending on the level of the input and output voltages, and to feed with the traction motors, we must have the DC to AC converter, that is the inverter. And nowadays, with the advancement of the different power semiconductor fabrication technology, as compared to the silicon materials that you could see, the latest, the research content is basically focused on the higher band gap switches or higher band gap the devices like silicon carbide and the gallium nitride, GN, silicon carbide, it is SiC. So these switches are going to be configured in comparison with the conventional silicon based switches that we need to have. And inverter, the designing is one of the very important contexts in the fuel cell hybrid electric vehicles, and controlling the mechanical parameters like the speed and torque of the traction motors, that one of the very important configurations, and the research engineers are basically working so enormously that to have a better dynamic behavior, like the torque speed characteristics of the traction motors in this particular context. But present research is concerned that permanent magnet synchronous motor, brushless DC motor, switched, the reluctance motor, as well as the presently the different aspects like the rare earth free magnets are basically going to be embedded. So different machine configurations and nowadays is one of the important aspect for the EV engineers exactly. But later on, the configurations like the transmission efficiency is one of the very important aspect in this fuel cell hybrid electric vehicle technology. That's why the direct drive motor or hub motor or in-wheel configurations of the electrical motors nowadays is going to be implemented over here, that you could see the particular electrical motors are fitted with the particular wheels exactly, and the speed of the wheels is nevertheless same as well as the speed of the electrical motors, in which a manner we could conclude that the transmission efficiency of this particular electromechanical energy conversion system may be enhanced. And definitely that the which I have been not mentioned, the battery. Nowadays, this particular fuel cell hybrid electric vehicle, battery and fuel cell must be integrated together. And in comparison with the battery and fuel cell, one ultra capacitor or super capacitor, or rather the flywheel technology, may also be incorporated as a hybrid energy storage system. And the sizing of the particular hybrid energy storage system is one of the very important consideration, and energy management strategy has to be considered for the the energy efficiency of the particular fuel cell hybrid electric vehicles, in line with the energy efficient environment for the sustainable electrification that we need to have exactly. So here, in comparison with the lectures that I have been already told you, that this is the schematic exactly, that while we are going to develop the powertrain or the drivetrain configuration, the fuel cell system, the DC to DC converter, the battery that we need to have, and DC to AC converter, vehicle accessories is one of the important consideration for the robust, the design over here, and the electrical motors, the transmission system, and finally the drive system, which the motion is transmitted to the wheels. So each and every block diagram is one of the very important context. And if you could see the one-way electrical power flow control, the two-way electrical power flow control, and the mechanical power flow control, that we need to be focused on. So those, the researchers are basically working on this fuel cell EV drivetrain configuration. So we must be emphasize that kind of the power flow control strategy, depending on the configuration, that is series parallel or series parallel or hybrid drivetrain configuration. So depending on the different configurations, here the power flow control strategies is one of the viable alternatives that power electronics engineers are basically working on tremendously, that how the next generation batteries are to be developed as compared to the lead acid and the lithium ion batteries, and the zinc batteries, the latest, the next generation, the battery technology, as well as the hybrid energy storage system is one of the important aspect in this particular technology. Not only that, the how the fuel cell stacks and how the batteries and how the ultra or supercapacitor technologies must be integrated together inside a common, the energy storage component exactly. And depending on that, the various configurations and various solutions, that when this particular arrangement or hybridization as well as the sizing could be taking place depending on the various operating environment of the particular electric vehicles, like the starting braking. And nevertheless, the regenerative braking is one of the very important aspect in this technology. While we must be emphasize that modern aspect of regenerative braking system must be adopted inside an EV powertrain technology, by which the motor may be acting as a generator, and some extra energy may be fed back to the supply, by which the battery storage capacity can be extended exactly. So that is one of the important aspect for the EV engineers to look into that, the particular operating characteristics of the motoring and braking operation, depending on the multi-quadrant operation or four-quadrant operation of an electrical drive system, and the dimension of the torque and speed that are going to be controlled in a precise manner, depending on the various road conditions and the transient operation of electrical drives, like the starting, braking, speed control, hill climbing operation, and the highway cruising operation, that we need to be focused. So here, the mathematical modeling of fuel cell hybrid electric vehicle may be taken into the consideration. Here, the like we all know that while we are going to develop any mathematical modeling, the subsystem configuration as well as the determination of the mathematical representation in terms of the system parameters is one of the important consideration for the researchers. So any softwares like MATLAB, Simulink, PSpice, PSIM, that may be taken care to develop the mathematical modeling, and the subsystem can be developed accordingly, depending on the particular mathematical, the assumption or the system parameters that we need to have. Here, in this particular cases, the fuel cell module, auxiliary system, the battery system, DC to DC converter, energy management system. One case study has been shown over here for your understanding. But till the time, I have not explained about what is energy management and techniques exactly. So energy management is one of the very important context for the hybrid electric vehicle configurations. Now, energy management strategy is basically the excellent overall system efficiency, and the range of the batteries that we need to be taken care of exactly, depending on the longer driving, the range that we need to have, and the extended lifespan of all the requirements. So as a very foundation concept that energy management strategy is one of the important consideration in case of hybrid electric vehicle configuration, as because this fuel cell technology as well as the battery technology, the combination of the energy storage component, that depending on the hybridization, that whatever the energy we are expecting and whatever the input energy and the output energy we are expecting for, so inside this input and output lots of processes are basically continuing, and so that the energy loss component is one of the important configuration. So to map with the input and output systems, so different energy dissipation factors may be taken into the consideration, and hence energy management is one of the important alternatives. And with the advancement of AI technology, the energy management that we could make it in a very precise and robust control operation, so that depending on the different configuration of the energy storage component, energy management engineers are nowadays basically focusing that depending on the energy storage and the driving conditions of the particular electric vehicle configuration, we need to have a proper or concrete mapping that at various conditions, that while we are going to implement the various control strategies that we need to have. And while talking about the control strategies, is the state machine control strategy, fuzzy logic control strategy, classical PI control method, the model predictive control, or as well as the sliding mode control, the important nonlinear control technique nowadays is going to be adopted to justify the energy management control technique that we need to have. So while talking about the fuzzy interference system, everyone may be familiar that the fuzzy is one of the important mathematical logic, and is basically based on the logic circuit, especially that fuzzy is a typically nonlinear control system, and based on that fuzzification, defuzzification, and the rule-based fuzzy logic that we need to develop accordingly depending on the input and output that we need to have. So fuzzifications, defuzzifications, fuzzy output, the membership functions that we need to be initiated, that depending on the variables, that it could be triangular membership function, it could be trapezoidal membership function, and depending on that we need to create the particular fuzzy logic. So depending on that logic, we need to have the input and output, and definitely the closed loop control action that we need to be taken care of to integrate the steady state, the errors, or the nearly zero steady state error, if we could consider a closed loop control action, especially the it could be the classical control, it could be different modern control, the robust control technique. But in this context, the fuzzy logic control is one of the very crucial control strategy by which we need to have the particular mathematical logic, and depending on the nonlinear control technique, that the stability consideration of the fuzzy logic control system is one of the important contexts that we are developing the different fuzzy logic, the rules. So in this context, the fuzzy plot has been shown over here for the system identification problems. So here the MATLAB plot has been shown over here. You could see the dynamic behavior comprises of the three parameters, like the the required power, the fuel cell power, and the state of the charge that could be taken into the consideration. So later on, while moving toward the state machine control strategy, can also be assumed as a kind of state machine system by which we could take that there is a transition from one state into the another state. And under this particular control strategy, the load power and the state of the charge of the batteries, that we could easily calculate the power of the fuel cell, I mean, power of the fuel cell stack. That is one of the important consideration. And here, absolutely, the classical PI control technique, everyone is familiar with classical PI control, the very simple, the proportional, integral, the regulator or the PI control technique is one of the very conventional control technique that we need to have. So based on that, PI control strategy may be one of the alternatives that we may be taken care as an energy management controller, out of which one mostly employed nonlinear control strategy nowadays, that due to the uncertainties and system parameters variations, the system uncertainties, the model predictive control strategy we may be adopted as an energy management controller. Exactly. So while looking on the flow chart or the process flow diagram, exactly that we are initializing the system state exactly, and afterwards we need to predict the system evaluations, and depending on the prediction, the optimal power distribution can be taking place. And while we need to have the optimal power flow distribution, then definitely energy consumption is one of the important. So we need to be considered that how much energy is consumed inside the powertrain of the fuel cell hybrid electric vehicle. Then depending on the comparison with the available power demand or the requirement, then we need to have a comparison logic, and based on that, the model can take care of. And finally, we need to predict or forecast the future, the requirement that we are basically looking for in this technology. And while the sliding mode control, that is one of the important aspect of the modern control techniques, may be taken care of the sliding surface and the system states that we must be declared over here, and computation of the control unit that under uncertainties, and the stability consideration is one of the very important context nowadays, exactly while we're integrating with the sliding mode control. And definitely depending on the system dynamic behavior, the dynamics or the aerodynamic features of a particular hybrid electric vehicle, that would also be investigated in this context. And depending on that, we need to have a sliding surface, and finally we need to take the the assumption of the controller, the output. So whatever the strategies that I have been discussed, the classifications of the energy management controller and the selection of the controller is one of the very important strategies for the research work nowadays. So to meet this, the subset of the artificial intelligence technologies that machine learning techniques nowadays has to be emphasized exactly to select the particular classifications problem in this context, exactly that we could see that the machine learning is one of the subset of the AI techniques by which we could be able to forecast or predict the future nature or future behavior of the different data sets that we are basically looking for to integrate the energy management strategy in this particular context. So depending on the machine learning approaches, the predictive control of the energy management systems that may be investigated, and nevertheless the fuel cell health monitoring, so the real-time health monitoring of the fuel cell technology is one of the important alternatives, as well as the state of the charge of a battery and performance optimization. And so definitely we need to be taken care. And depending on that, we could see the supervised learning as well as the unsupervised learning, or it could be the reinforcement learning. Maybe the computer science people are much more expert in this field, but as far as I know, some of the research scholars are basically working under me, so I know very little bit about this technology. But you could see the supervised learning, it is basically based on the past or the labeled the data, and unsupervised learning means it does not have any labeled the data. And unsupervised learning is basically identifying the pattern recognition, anomalies, and deviations in the input data set, and based on that the reinforcement learning, which could learn based on the rewards that it may be for its previous action or the past action. So depending on the machine learning steps that I have been trying to focus you in this particular context, that the data sets are one of the very important alternatives that to emphasize for the machine learning algorithm, because while we don't have the adequate or large number of the data set of the energy management control parameters, until and unless we could not able to apply the promising machine learning approaches, and definitely the accuracy, sensitivity, and all the predictive natures that we are looking for, that we may be lost over here exactly. So one thing that I would like to show you, the collection of the data set and training and testing of the data sets is one of the very important process diagrams that we need to be taken care of. And finally, depending on the training, testing, as well as the learning processes of the various the data sets of the fuel cell hybrid electric vehicle configurations, we need to have a predictive control or forecasting to integrate the energy management solution. Here some test bench that has been shown over here, where you could see the real-time embedded controller that has been shown over here, the test the rig, and inside this test rig internal layout configuration has been shown over here. So here the different inverters, the batteries are basically electrically connected over here, and you could see the left one, this is also a powertrain configurations, where the powertrain configuration is basically based on the PMSM drive system, or it could be the BLDC motor drive system that we need to have, and different capturing units that we must be incorporated over here. And the real-time controller is one of the important alternatives that in this solution, so that in this particular test rig or test the hardware testing, that we need to we need to impose the various kinds of the algorithms and the real-time testing, or rather you could say the HIL or hardware in-loop operation that could be taking place exactly. And we are going to capture the different kinds of the data sets through the the real-time controller that we need to have. And based on the collections of the different data set, the AI or machine learning techniques. So here I would like to just giving you that whatever the overall scenario, that each energy management controllers have been taken care. So the 4 parameters are taken care in this case: the battery state of charge, hydrogen consumption, overall efficiency, and the battery stress. And we need to have a comparative performance evaluations of the different control techniques, comprises of MPC control, ECMS control, the sliding mode control, fuzzy logic control, and PI control. And based on that, that we could see the MPC control, the state of the charge is 70 to 60% hydrogen consumption, as well as overall efficiency of the MPC control as compared to the ECM logic control, the strategy is 80.27% as compared to the ECMS and PI control that we need to have. And as in this particular context, the classifications of the machine learning approaches, as per my knowledge, that could be summarized as the support vector, the machine that is, the SVM, the classifier fusion technique, k-nearest neighbor, naive Bayes algorithm, and later on the bi-LSTM approaches. So basically, here what I would like to show you, machine learning approaches are basically classified into several categories, and depending on that, we need to select one particular machine learning approaches depending on the classification problem and depending on the nature of the data set that we have been collected, and depending on the system requirements that the computer science people are basically working on, that which classification problem that would be the best solution to integrate the energy management system. And here, just I would like to tell you that by support vector machine, classified fusion technique, the nearest neighbor, and lastly the bi-LSTM is one of the competitive machine learning approaches, because it is so-called the long short-term memory, I feel, and it is renowned for its proficiency in capturing the long-term dependencies. And bi-LSTM is basically employing the two LSTM approaches exactly. The first LSTM is handling the original sequence in the forward direction, and second LSTM is basically focusing in the backward direction of the input approaches. So as compared to the other approaches, bi-LSTM approach could be enhancing the model capability that to grab the information from both the past and the futures, thereby the refining the proficiency in analyzing the sequential problem that we need to have. Now, while talking about the SVM classification problem, is one of the very fundamental machine learning approaches, the support vector machine, depending on the training data set, the kind of controller that we are going to select, either it is MP control or either it's a rule-based fuzzy logic control. Based on that, the feature extraction could be taking place, and after the extraction of the features, exactly, the training system that must be incorporated, training and testing systems, we need to have the classifications of the SVM technique, and finally we need to have the particular selection of the controller, that is MPC or RBFL in this particular strategy. And while performing with this incremental features selection, employing the classification SVM problem, the accuracy that the features that has been taken care, that you could see that only the battery capacity and the battery stress is taken into the consideration, the accuracy was 90%. Additionally, while the battery capacity, battery stress, and the range of EV mode are basically integrated together, the accuracy could be enhanced to 95%. And thirdly, that the battery capacity, stress, range, and the fuel tank capacity, the four number of the features vector sets are taken into the consideration, the accuracy is going to be enhanced to 98%. And this is one of the important classifications problem, that is the classified fusion technique. And you could see the electric vehicle, the data set, the feature extraction of optimal feature selection, and based on that, the three classifications problem has been taken care of from KNN and naive Bayes algorithm, and based on that, the classification problem, we have a classifier fusion technique by which the final decision to be taking place, that is simply 0 and 1 that we need to taking place. So finally, we could conclude that the classifier fusion technique is one of the subset of the machine learning classification problem, which is involving the combination of the output of the multiple classifiers in order to improve the overall performance and to enhance the robustness in the context of the classifications problems that we need to have. And we are going to have the optimal features, exactly the selections. You could see the different classifications are basically taken care in this particular problem, and the আচ্ছা আচ্ছা, দেখো তো এবার। হ্যাঁ, ওকে, ফাইন ফাইন, ওকে। Okay, so here I would like to conclude it, and as a conclusion, I would like to conclude that the energy management strategy of a fuel cell hybrid electric vehicle is one of the important alternatives to investigate the different performance classifications in terms of the fuel cell fuel tank capacity, energy storage, the requirement, the driving, the range condition, and ultimately the overall performance of the hybrid electric vehicle configurations. And based on the themes, I have been shown you the different, the AI and ML approaches to investigate the energy management solution for the sustainable electrifications uh, around the globe. And I I would like to express my hearty thanks to all the participants for your kind presence. If you are having any sort of the doubt, you may please ask me. I am very happy to answer. Hello.
Any questions from the participants here? Kindly let us know. Any queries? Is there any queries from participants in? Okay. I hope, sir, they do not have any queries. Okay, but it is very good and informative session. Okay, so I hope there is a new kind of study we can able to carry on this topic and this directions. Okay, let me check any questions. Acha, one question is coming that how to get training data set.
Okay. Yeah. This is a very good query that we do have exactly. The training data set is one of the very important tasks for the EV engineers, especially exactly. In this particular case, what we have been particularly taken care of, that the fuel cell hybrid electric vehicle, especially, we have been collected the different, the real world driving the data set exactly. And depending on the particular industry that we have been covering the real world driving the data set, we need to have a we need to have a particular the what I could see, the data compression exactly. And as compared to the practical data available, we need to have a we need to have a particular emphasizement on the particular number of the data set. And depending on the variations of the data set and the system requirements exactly, we have been taken care of the particular training data set, and depending on the training data set, the testing could be taking place. But the raw data collection is one of the important tasks in this particular aspect. And what we have been especially done over here, we have collected the real world driving data set from the relevant industry. And depending on that, we need to have a concrete the data set. And based on that, the selection of the data set, and we have been particularly performed the particular classification problem, and based on that, the training data sets have been taken out.
Okay, sir. Sir, there is another one question.
Yeah.
When we want to start research in energy management in EV,
Yeah.
what is the plan we need to follow from where we need to start?
Yeah, this is a very foundation problem that we do have exactly. At the foremost, I would like to convey you that a energy management strategy or energy management control to investigate actually that foundation of the power electronics power system is very, very important. And depending on that, the power electronics and power system and the control systems, the fundamental subject especially that we need to have. And based on that, we need to gradually develop for the energy management system or the power flow control, the strategies that we may be looking for. And based on that, the physical, the realization is one of the very important tasks to investigate the energy management control issue. But before that, what I like to suggest that to study energy management system, the practical data set collection is one of the very, very important context. For an example, I would like to tell you that inside our home or household or every practical case study, or it could be household or any the domestic power supply that we need to have. So energy management is one of the very viable and common solution that whatever the electrical appliances that we need to have, and based on that energy consumption, the losses, energy losses, and energy efficiency that we need to be taken care of, and different auditing can be taken place nowadays, and we can easily investigate the energy management issue based on that.
Okay, so another queries
Yeah.
that any sources for dataset collections and in
Yeah,
industry means please when he has two questions at the moment. Any sources for dataset collections and industry means please. He's asking the question.
Yeah, yeah, definitely. I would like to give you the source. Actually, source in the sense is that if you could visit the the different actually the websites that if you could see the Niti Aayog, like for an example, the Atmanirbhar Bharat, or the different aspects of the the what I could say presently I could not able to recall. But the thing is that the electric mobility industries, if you especially visit, and if you really try to physically visit over there, those industries are basically looking for to mitigate the different energy management issues of the EV technologies. And based on this particular EV model, firstly, I would like to suggest you that you try to select one particular EV.
Okay, so another small query telling that optimization and energy management in EV. This is one of my objective in research. When I think Madam is asking, Madam Sheila or Orunathan, sorry, Orulathan is asking that can we put some lights in this? Means she is asking that optimization and energy management in EV. This is one of my objective in research. Can he thought some lights on this? She is asking. Hello. Hello.
Hello, hello, Arnab sir.
You're audible. Okay, am I
Yeah, yeah,
audible?
yeah.
Ha,
Please, yeah.
One esteemed participant just asked that optimization and energy management in EV. Actually, this is her. She is writing like that optimization and EV. Sorry, optimization and energy management in EV. This is one of my objective in research. Can he throw some light in this? He is asking.
Yeah, definitely, because as I have already told lots of things actually, energy management techniques and the optimization is nowadays very hot cake exactly. So the optimization techniques that every is, for an example, it could be soft computing algorithm, bio-inspired algorithms, meta heuristic techniques, AI techniques, machine learning approaches. So different optimization techniques nowadays have been tremendously applied in this particular field, and based on the particular system parameters or identification problem that the researchers need to fix the particular kind of optimization, and based on the controller performance that we need to investigate and classifications problem, and based on that we need to apply the particular optimization problem to investigate the energy management issues in this particular context. So I would like to conclude that while we are going to adapt with these particular optimization techniques, we must be incorporated about the various system parameters or identifications or the uncertainties problem, and based on that the range of the parameters, that whatever the range we are going to tune in order to have the optimal system performance exactly that we may be taken care of.
Okay, sir. Thank you. Thank you very much for your insightful discussion. And the topic is very good. And I hope that our esteemed participants can learn and a lot of things from this presentation. Okay, so thank you so much for giving us your valuable time and your sharing your ideas with us. Thank you, sir.
Yeah, lastly, again, I do hereby actually apologize for
No,
the
sir. Actually, sir, I'm just telling you one
issues
point.
actually.
As the course is going on in virtual mode, na, so this happened. This is part of the consideration. There is no point of apology because we all are meeting virtually. So in that discussion, a lot of persons from different areas of our country. So maybe some portions network issues may be done. Okay, because we all are trying our level. So there is no point of apology, sir. This is part of the consideration. No issue, sir. Please, if you asking apology, then I hope participants also not feeling, they are also not feeling good. It's happened, sir. Nothing. No worries, sir. Don't worry, sir. So, okay, sir. Thank you, sir, for giving us your valuable time, sir.
Okay, bye. Thank you all. Thank you.
Thank you, sir. So all the esteemed